It feels like one day we all woke up and suddenly artificial intelligence wasn't just science fiction anymore. It was everywhere. Tools like ChatGPT and Gemini seem to pop out of nowhere, and they're totally changing how we do, well, everything. But here's the thing. This overnight revolution was actually decades in the making. So, how in the world did we get here?
All right, so let's get right into it. The story of modern AI is really the story of a mystery. How did a technology that was stuck in a 50-year AI winter with almost no funding or interest suddenly explode into the thing everyone is talking about? To figure that out, we've got to rewind the clock.
So, the big idea behind all of this? It's called machine learning. And before we can get to the cool, flashy stuff, we really need to get our heads around what it even means for a machine to learn. Because, spoiler alert, it's not about programming a computer with a million if-then rules. It's way more interesting than that.
Now, this definition might look a little academic, but it basically boils down to something super simple. A system gets better at a task just by doing it. The more experience it gets, and by experience we just mean more data, the better its performance gets. It's not about being hard-coded with rules. It's about learning them from examples.
So, if you want to build a learning machine, where do you look for inspiration? Well, you look at the best one we know of, the human brain. And that's exactly what researchers did. They created these things called artificial neural networks. They're basically computing systems made of interconnected neurons that are designed to process information in a similar way. This idea is the bedrock of pretty much all modern AI. You don't code the rules. You build a network and let it learn from the data you give it.
But here's where the story gets really interesting. This idea, it's not new. Not at all. We're talking more than 70 years old. And for most of that time, despite some brilliant theories, progress was moving at a snail's pace.
I mean, just look at this timeline. The basic math, figured out in the 40s. The first actual learning algorithm, the perceptron, 1958. Even backpropagation, which is, the engine that trains all these modern networks, that was developed back in the 70s. All the key ingredients were there, but they just kept hitting a brick wall. This led to the infamous AI winter, when funding dried up and most people thought the whole idea was a dead end. So what gives? What was the big roadblock?
It boiled down to one thing and one thing only: a massive, massive lack of raw computing power. The ideas were decades ahead of the hardware. Early computers were just way too slow to handle these complex networks, which meant they could only solve tiny, toy-sized problems. The dream was there, but the horsepower wasn't. And for decades, that was the end of the story. Until suddenly, it wasn't.
And this is where everything changes. That long AI winter, it didn't just end with a little spring thaw. It ended with a full-on supernova-level explosion. This was the moment deep learning finally delivered on decades of promise.
What you're looking at here is basically the big bang of modern AI. The year is 2012. A neural network called AlexNet enters this big image recognition competition. And it doesn't just win, it demolishes the competition. See that huge drop? It slashed the error rate from over 25% all the way down to 16%. That was a game changer. It was like a light bulb went on for the entire world. Okay, with enough data and enough compute, these things are the future.
But here's the crazy part, a real paradox. Right when AI develops this insane appetite for more and more computing power, traditional computers start to run out of steam. You've probably heard of Moore's Law, right? The idea that CPUs get twice as fast every couple of years? Well, as you can see from this chart, that party was pretty much over. Performance gains were slowing to a crawl. So you get this incredible split. While regular computer chips are slowing down, the amount of compute needed for the next big AI breakthrough is doubling, get this, every 3.5 months. That's not a typo. The result was a 300,000-fold increase in demand in just a few years. Your standard hardware had no chance. It created a desperate need for a whole new class of chips built from the ground up just for AI. So this deep learning revolution wasn't just about building faster hardware. It also unlocked completely new things that AI could do. And that's what kicked off the generative AI race we're seeing today. And it was really built on a couple of key technological breakthroughs. First up, we have something called GANs. And the idea here is just brilliant. It's like you have two AIs in a competition. One is an art forger, the generator, trying to create fake images. And the other is an art critic, the discriminator, trying to spot the fakes. They go back and forth, and as they compete, the forger gets so good that its creations become indistinguishable from the real thing. It's how we got those first super realistic AI-generated images. And then,
Then came the transformer. This was the one that changed everything for language. It came from a 2017 paper with the best title ever, Attention is All You Need. And attention is the key word. It's a new kind of architecture that lets a model understand the relationships between all the words in a sentence, no matter how far apart they are. That ability to grasp context, that is the secret sauce behind large language models like GPT.
And once these technologies were out in the wild, the race was on. It sparked this massive competition between the tech giants. You had OpenAI coming out of the gate strong with its GPT models, Google fired back with Gemini, and now you've got other major players like Anthropic jumping in with models like Claude 3, which is topping the charts on a bunch of important tests. It is a full-on arms race for AI supremacy.
Okay, so where does all this leave us? We're living in a brand new world, a world defined by these giant AI supercomputers, some pretty serious new challenges, and a future that honestly is being written in real time.
To feed that hunger for computation we talked about, companies had to build computers on a scale that's just hard to wrap your head around. What you're looking at here is one of Google's TPU pods. It's an AI supercomputer. And I don't just mean a big server. We're talking more than 1,000 custom-built chips, all networked together, delivering over 100 petaflops of raw power. This is the massive, warehouse-sized machine it takes to train today's most advanced AI.
And the chips inside these machines are a whole different beast. They pull off this really clever trick to get all that power. They're actually less precise than a normal computer chip. Turns out, for AI, you don't need hyper-accurate numbers down to the 16th decimal place. Good enough is, well, good enough. And by dropping that unnecessary precision, engineers can cram way more raw computing horsepower onto every single chip.
But all this incredible power brings some really serious challenges. I mean, the environmental footprint is huge, and since these models learn from us, from all the text and images on the internet, they can pick up and even amplify our worst biases. And of course, there's the whole problem of disinformation, fake images, and other harmful content. These aren't just thought experiments anymore. They're real problems we have to deal with, right now.
So, where do we go from here? Well, the next big thing researchers are working on is a totally new way to build these models. Right now, it's like having one giant brain, where every single neuron fires for every single task. The new idea is called a sparsely activated model. Think of it less like one giant brain and more like a huge team of specialized experts. When a new problem comes in, the AI figures out which 2 or 3 experts are perfect for the job and only sends the task to them. This could make AI way, way more powerful and efficient.
And that brings us to the final mind-bending question. We've gone from the AI winter to an explosion of specialized models. The next frontier, the next holy grail, is to build a single system that can learn millions of different tasks, language, vision, robotics, you name it, and then use that knowledge to solve problems it has never ever seen before. So the question is, what happens when a single AI can do all that? What does our world look like then? That's the next chapter, and it's just getting started.